Imagine a world vastly different from our own, a world where the landscape is dominated by immense glaciers and colossal ice sheets that stretch as far as the eye can see. This is a time when the Earth is gripped by the cold embrace of the Ice Age, a period that has left an indelible mark on the planet's history. Picture the relentless advance and retreat of these glaciers, carving out valleys, shaping mountains, and transforming the very face of the Earth. These massive ice flows are not just static features, they are dynamic forces that have sculpted the world we know today. This was the Pleistocene Epoch, a period spanning from about 2.6 million to 11,700 years ago, often referred to as the Ice Age. It is a time frame that encompasses numerous glacial and interglacial periods, each with its own unique climatic characteristics and environmental challenges. During this time, the planet experienced dramatic climatic fluctuations, with long periods of intense cold interspersed with milder interglacial periods. These shifts in climate had profound effects on the environment, influencing everything from sea levels to the distribution of plant and animal species. These environmental shifts had a profound impact on life on Earth, driving the evolution of new species, including our own genus, Homo. The challenges posed by the changing climate forced species to adapt, evolve, or face extinction. As the Pleistocene progressed, a remarkable group of hominins, now extinct, emerged on the evolutionary stage, the Neanderthals. These ancient humans were uniquely adapted to the harsh conditions of the Ice Age, with robust bodies and specialized tools that allowed them to survive in a world that was often unforgiving. These ancient humans, our closest extinct relatives, inhabited parts of Europe, Southwest Asia, and Central Asia, enduring the harsh realities of a glacial world. They were skilled hunters, capable of taking down large game such as mammoths and woolly rhinoceroses, and they developed complex social structures to support their communities. Their story is one of resilience, adaptation, and a surprising degree of cultural complexity, a story that has captivated scientists and the public alike for over a century. Neanderthals created tools, built shelters, and even engaged in symbolic practices such as burying their dead with care and possibly creating art. The discovery of the first Neanderthal fossils in the mid-19th century marked a turning point in our understanding of human evolution. These fossils provided the first concrete evidence that modern humans were not the only hominins to walk the Earth, challenging long-held beliefs about our uniqueness. It challenged the prevailing view that modern humans were unique and alone in their lineage, revealing instead a more intricate tapestry of human ancestry. The Neanderthals were not just primitive brutes, they were a sophisticated and capable species that shared many traits with us. Over the past century and a half, painstaking research and remarkable fossil discoveries have gradually unveiled the secrets of these enigmatic people, shedding light on their appearance, behavior, and their place in our own evolutionary journey. Scientists have reconstructed their physical features, studied their tools, and even extracted DNA to learn more about their genetic legacy. As we delve deeper into the world of the Neanderthals, we will uncover the remarkable story of their existence, exploring their origins, their adaptations to challenging environments, their sophisticated tool-making abilities, and their capacity for symbolic thought. We will examine how they lived, what they ate, and how they interacted with their environment and each other. Join us as we journey back in time to meet our ancient cousins, the Neanderthals, and gain a deeper appreciation for the rich tapestry of human history. Through this exploration, we will not only learn about the Neanderthals, but also gain insights into our own species and the shared heritage that binds us together. The Pleistocene Epoch was also home to a diverse array of megafauna, including saber-toothed cats, giant ground sloths, and the iconic woolly mammoths. These creatures roamed the vast, icy landscapes, each uniquely adapted to the cold and often harsh conditions of the Ice Age. Their presence added to the complexity and richness of the ecosystems of the time. The interaction between Neanderthals and these megafauna was crucial for their survival. Neanderthals were skilled hunters, and their ability to track and hunt large game was a testament to their ingenuity and adaptability. They developed sophisticated hunting strategies and tools which allowed them to thrive in an environment where resources were often scarce. Neanderthal social structures were complex and closely knit. They lived in small family groups and larger communities where cooperation and social bonds were essential for survival. Evidence suggests that they cared for their sick and elderly, indicating a level of empathy and social responsibility that was once thought to be unique to modern humans. Neanderthals were also adept at creating shelters to protect themselves from the harsh elements. They utilized natural caves and constructed temporary structures using available materials such as bones, hides and wood. These shelters provided them with a safe haven from the cold and a place to gather and share resources. The Neanderthal diet was varied and included both plant and animal sources. They were omnivores, consuming a wide range of foods depending on what was available in their environment. Evidence of cooking and food preparation suggests that they had a sophisticated understanding of nutrition and food safety. One of the most intriguing aspects of Neanderthal life is their capacity for symbolic behavior. There is evidence to suggest that they engaged in artistic expression and created personal ornaments. Their burial practices, which often included grave goods, indicate a belief in an afterlife or a form of ritualistic behavior. The genetic legacy of the Neanderthals lives on in modern humans. Through interbreeding, Neanderthals contributed to the genetic makeup of contemporary human populations. This genetic exchange has provided us with valuable insights into their biology and has helped to shape our understanding of human evolution. Modern scientific techniques, such as DNA analysis and advanced archaeological methods, have revolutionized our understanding of Neanderthals. These tools have allowed researchers to uncover new information about their lives, their interactions with other species, and their eventual decline and extinction. The reasons for the extinction of the Neanderthals remain a topic of ongoing research and debate. Theories range from climate change and environmental pressures to competition with modern humans. Understanding the factors that led to their disappearance can provide valuable lessons for our own species as we face similar challenges today. The legacy of the Pleistocene Epoch extends beyond the Neanderthals. The dramatic climatic changes and geological processes of this period have left a lasting impact on the modern landscapes we inhabit. The glaciers that once dominated the Earth have receded, but their influence can still be seen in the valleys, lakes, and other features they carved out. Reflecting on the Pleistocene Epoch and the story of the Neanderthals offers a powerful reminder of the resilience, adaptability, and ingenuity that are hallmarks of the human species. By studying our ancient relatives, we gain a deeper appreciation for the challenges they faced and the ways in which they overcame them. As we conclude our journey through the Pleistocene Epoch, we are reminded of the profound connections between the past and the present. The landscapes shaped by the Ice Age continue to influence our world today, and the story of the Neanderthals remains a testament to the enduring spirit of humanity. Join us as we continue to explore the rich tapestry of our shared history and uncover the secrets of our ancient past.
The story of the Neanderthals is intricately woven into the broader narrative of human evolution, a story that began in Africa millions of years ago. While the precise evolutionary path leading to Neanderthals remains a subject of ongoing research, the fossil record suggests that they shared a common ancestor with our own species, Homo sapiens, likely Homo erectus, who lived approximately 1.8 million years ago. Around 400,000 years ago, during the Middle Pleistocene, the lineage that would give rise to Neanderthals diverged from our own. These early Neanderthals, known as early or archaic Neanderthals, began to exhibit some of the distinctive physical traits that would later characterize their descendants. These early Neanderthals inhabited parts of Europe and Asia, gradually adapting to the colder climates that were becoming increasingly prevalent during this period. The fossil record provides tantalizing glimpses into the lives of these early Neanderthals, with sites such as Cima de los Huesos in Spain yielding a treasure trove of skeletal remains. These fossils suggest that early Neanderthals were robustly built, with strong muscle attachments and a pronounced brow ridge, features that would become even more pronounced in their later descendants. As the Pleistocene progressed and glacial cycles intensified, the Neanderthal lineage continued to evolve and adapt. By around 130,000 years ago, during the late Pleistocene, Neanderthals had emerged as a distinct species, Homo neanderthalensis. These classic Neanderthals, as they are often called, possessed the full suite of physical characteristics that distinguish them from other hominins, including their robust skeletons, prominent brow ridges, and a distinctive skull shape with a large nasal opening.
Neanderthals were remarkably well suited to the challenges of their Ice Age environment. These ancient humans, who lived between 400,000 and 40,000 years ago, developed a range of physical and cultural adaptations that enabled them to survive and even thrive in some of the harshest climates on Earth. Their physical characteristics, honed by generations of natural selection, reflect a suite of adaptations that allowed them to thrive in cold, often unforgiving landscapes. These adaptations were not just limited to their physical form, but also extended to their behaviors and tool use, which were crucial for their survival. One of the most striking features of Neanderthals was their robust build. This build was not just for show, it was a vital adaptation that helped them endure the physical demands of their environment. Compared to modern humans, Neanderthals were shorter and stockier, with a barrel-shaped chest and powerful limbs. This compact body shape helped them conserve heat, a crucial advantage in the frigid Ice Age climates. Their bones were thicker and denser than ours, indicating a high degree of muscularity. This muscular build was essential for their survival, as it provided the strength needed for hunting large game and performing other physically demanding tasks. This robust physique would have been advantageous in the cold climates they inhabited, providing insulation and strength for demanding tasks such as hunting large game and traversing rugged terrain. Their ability to hunt large animals like mammoths and woolly rhinoceroses was a testament to their strength and endurance. Neanderthals also possessed a distinctive skull shape that set them apart from other hominins. This unique cranial structure was another key adaptation that helped them survive in their challenging environments. Their skulls were long and low, with a pronounced brow ridge, or supraorbital torus, above the eyes. This feature was not just a random trait, but likely served several important functions. This prominent brow ridge, a characteristic shared with their early Neanderthal ancestors, may have served several functions, including providing structural support for their large faces and protecting their eyes from injury. It also may have played a role in social signaling and communication. Another notable feature of Neanderthal skulls was their large nasal aperture, or nasal opening. This feature was particularly well suited to their cold environments. This unusually large nasal cavity has been the subject of much speculation among scientists. It is believed to have been an adaptation that allowed Neanderthals to warm and humidify the cold, dry air they breathed. Some researchers believe it may have been an adaptation to cold, dry climates, allowing Neanderthals to warm and humidify the air they breathed more efficiently. This would have been crucial for maintaining respiratory health in freezing conditions. The Neanderthal physique, with its unique combination of skeletal features, provides compelling evidence of their remarkable adaptation to the challenging environments they called home. Their physical form was a testament to their resilience and ability to adapt to their surroundings. Their robust build, powerful musculature, and distinctive cranial features all point to a life lived in close concert with the demands of a glacial world. These adaptations were not just about survival, but also about thriving in a world that was as beautiful as it was harsh. Moving beyond their robust build, Neanderthals possessed a suite of anatomical features that further distinguished them from their modern human counterparts. These features were not just superficial differences, but were deeply rooted in their biology, reflecting the unique evolutionary path they took. The Neanderthals, who lived in Europe and parts of Asia from around 400,000 to 40,000 years ago, adapted to a variety of harsh climates and environments. Their anatomy tells a story of survival, resilience, and adaptation. Their limbs, while powerfully built, were proportionally shorter than ours, a characteristic often seen in animals adapted to cold environments. This adaptation is known as Allen's rule, which states that endothermic animals in colder climates tend to have shorter limbs to minimize heat loss. Neanderthals' shorter limbs reduced the surface area through which heat could escape, helping them retain warmth in the frigid Ice Age climates they often inhabited. This anatomical feature was crucial for their survival, as it allowed them to maintain a stable core temperature even in the most extreme conditions. This stocky build, with its lower surface area to volume ratio, would have helped to conserve body heat in frigid climates. The Neanderthals' robust physique was not just about strength, it was a finely tuned adaptation to their environment. Their broad chests and muscular bodies provided additional insulation and energy reserves, which were vital during periods of food scarcity. This build also supported their active lifestyle, which involved hunting large game, gathering resources, and possibly even engaging in complex social behaviors that required significant physical exertion. Their hands, too, differed from ours in subtle but significant ways. Neanderthal hands were adapted for power rather than precision. The structure of their fingers and thumbs suggests they had a strong grip, which would have been advantageous for tasks such as tool-making, hunting, and building shelters. Their hands were capable of exerting significant force, allowing them to manipulate heavy objects and perform tasks that required considerable strength. This powerful grip was a key aspect of their daily survival, enabling them to create and use tools effectively. Neanderthals had relatively larger fingertips and a more powerful grip, suggesting a lifestyle that involved frequent and forceful manipulation of objects, perhaps related to tool-making or other survival tasks. Their tools, known as Mousterian tools, were sophisticated and varied, indicating a high level of skill and knowledge. These tools included scrapers, points, and blades, which were used for hunting, butchering animals, and processing plant materials. The ability to create and use such tools was a significant advantage, allowing Neanderthals to exploit a wide range of resources in their environment. Their feet, while generally similar in structure to our own, also exhibited some intriguing differences. Neanderthal feet were robust and well-suited for walking long distances over rough terrain. The structure of their feet suggests they were adapted for stability and endurance rather than speed. This would have been beneficial in their environment, where they needed to traverse uneven ground, climb, and possibly even run in pursuit of prey. The differences in their foot structure also hint at a unique gait, which may have been more energy efficient for their lifestyle. Some researchers have suggested that Neanderthals may have had a slightly different gait than modern humans, possibly related to the demands of navigating uneven or icy terrain. This gait, characterized by a more upright posture and a rolling motion of the foot, would have provided better traction and stability on slippery surfaces. It also suggests that Neanderthals were highly adapted to their environment, capable of moving efficiently and safely across challenging landscapes. This unique way of walking would have been an important adaptation, allowing them to hunt, gather, and travel effectively in their harsh surroundings. These anatomical nuances, though seemingly minor, provide valuable clues about the Neanderthal way of life, hinting at the challenges they faced and the adaptations they evolved to overcome them. Each feature, from their robust limbs to their powerful hands and unique gait, tells a story of a species finely tuned to its environment. These adaptations were not just about survival, they also reflect the Neanderthals' ability to thrive in diverse and often harsh conditions. Their anatomy reveals a complex interplay between biology and environment, highlighting the remarkable resilience and ingenuity of this ancient human species. Further examination of the Neanderthal skeleton reveals additional clues about their physiology and lifestyle. Their bones were thicker and denser than those of modern humans, indicating a physically demanding lifestyle. This robust skeletal structure provided the strength and durability needed for their daily activities, which included hunting large animals, building shelters, and possibly even engaging in social and cultural practices. The study of Neanderthal bones, has also provided insights into their health and diet, revealing a species that was both resilient and adaptable. Their ribcage, for example, was broader and more barrel-shaped than ours, providing ample space for their large lungs, a feature that may have enhanced their respiratory capacity in cold, dry air. This adaptation would have been crucial for surviving in the cold, oxygen-poor environments they often inhabited. The large lung capacity would have allowed them to take in more oxygen with each breath, supporting their high-energy lifestyle and helping them maintain their body temperature in freezing conditions. This feature also suggests that Neanderthals were highly active, requiring a robust respiratory system to support their physical exertion. Their pelvis, too, differed from ours, being wider and more robust. This difference in pelvic shape has been a subject of much debate among scientists, with some suggesting it may reflect adaptations for childbirth in a cold climate or for supporting their powerful leg muscles. A wider pelvis would have provided a stable base for their strong legs, enhancing their ability to walk, run, and carry heavy loads. It may also have facilitated childbirth, allowing for the delivery of larger-brained infants. This feature highlights the complex interplay between anatomy and environment, reflecting the unique challenges and adaptations of the Neanderthal species. This difference in pelvic shape has been a subject of much debate among scientists, with some suggesting it may reflect adaptations for childbirth in a cold climate or for supporting their powerful leg muscles. The robust pelvis would have provided the necessary support for their muscular legs, which were essential for their active lifestyle. It also suggests that Neanderthal women may have faced unique challenges during childbirth, possibly requiring different birthing practices compared to modern humans. This aspect of their anatomy provides valuable insights into their reproductive biology and the evolutionary pressures that shaped their development. Each of these anatomical details, meticulously studied by paleoanthropologists, contributes to a growing portrait of Neanderthals as a distinct human species, shaped by the relentless forces of evolution to thrive in the challenging environments they called home. The study of Neanderthal anatomy not only reveals their physical adaptations, but also provides a window into their daily lives, behaviors, and interactions. By understanding their anatomy, we gain a deeper appreciation for their resilience, ingenuity, and the complex interplay between biology and environment that defined their existence. The Neanderthals were not just primitive humans, they were a unique and highly adapted species whose legacy continues to intrigue and inspire us today. Section 2. Built for the cold. Adaptations to glacial climates. The Pleistocene Epoch, during which Neanderthals flourished, was a time of dramatic climatic fluctuations, with glacial periods characterized by advancing ice sheets and frigid temperatures. These conditions were harsh and unforgiving, demanding significant adaptations for survival. To survive in these harsh environments, Neanderthals evolved a suite of physiological adaptations that allowed them to cope with the cold. These adaptations were not just physical, but also behavioral, showcasing their remarkable ability to innovate and adapt. One of the most notable of these adaptations was their body shape. This was a critical factor in their survival, as it directly influenced their ability to retain heat and endure the cold. As mentioned earlier, Neanderthals were stockier and more robustly built than modern humans, with shorter limbs and a barrel-shaped chest. This robust build was not just a random trait, but a well-adapted feature for their icy habitats. This compact body shape, with its lower surface area to volume ratio, would have helped to minimize heat loss, a crucial advantage in cold climates. The reduced surface area meant less exposure to the cold, thereby conserving precious body heat. In addition to their overall body shape, Neanderthals also possessed a number of other adaptations that enhanced their ability to conserve heat. These included both anatomical and physiological traits that worked together to ensure their survival. Their large nasal aperture, while its exact function remains a subject of debate, likely played a role in warming and humidifying the cold, dry air they breathed. This would have been essential for maintaining respiratory health in freezing conditions. Their bodies may have also produced higher levels of certain hormones, such as thyroid hormone, that are involved in regulating metabolism and heat production. This hormonal adaptation would have been crucial for generating internal heat. Furthermore, recent research suggests that Neanderthals may have had a higher basal metabolic rate than modern humans. This higher metabolic rate would have enabled them to generate more body heat, a vital adaptation for surviving in cold climates. This means that their bodies would have burned more calories at rest, generating more heat in the process. While this would have required them to consume more food, it would have been a significant advantage in cold climates, where maintaining body heat was a constant challenge. While this would have required them to consume more food, it would have been a significant advantage in cold climates. Their diet, rich in protein and fat from hunting large game, would have supported this high caloric intake. These physiological adaptations, combined with their behavioral adaptations, such as the use of fire and tailored clothing, enabled Neanderthals to not only survive, but to thrive in some of the most challenging environments ever faced by our hominin ancestors. Their ability to create and use tools, build shelters, and make clothing from animal hides further exemplifies their ingenuity and resilience in the face of extreme conditions. Section 3. The Neanderthal brain, size and complexity. The Neanderthal brain has been a topic of intense scientific scrutiny for over a century. Early reconstructions of Neanderthals often depicted them as brutish and unintelligent, but fossil evidence tells a different story. Neanderthal brains were, on average, slightly larger than those of modern humans, although brain size alone is not a direct measure of intelligence. Endocasts, impressions of the inner surface of the skull, provide insights into the structure and organization of the Neanderthal brain. These endocasts reveal that while Neanderthal brains shared some similarities with our own, there were also some intriguing differences. For example, the Neanderthal occipital lobe, the part of the brain involved in visual processing, appears to have been proportionally larger than that of modern humans. This suggests that vision may have played a particularly important role in their sensory world. Conversely, their frontal lobe, the seat of higher cognitive functions such as planning, decision-making, and abstract thought, was proportionally smaller than ours. However, it is crucial to note that size is not the only factor determining cognitive abilities. Recent research suggests that the Neanderthal brain may have been organized differently than ours, with different regions interconnected in unique ways. This suggests that while Neanderthals may have processed information differently than we do, they were likely capable of complex thought and behavior. The Neanderthal brain, with its intriguing combination of similarities and differences from our own, continues to fascinate and challenge our understanding of human evolution. Section 4. Sensory perception, sight, smell, and sound. The world of the Neanderthals was a sensory-rich environment, filled with the sights, sounds, and smells of the Pleistocene Epoch. While we can only speculate about the nuances of their sensory experiences, fossil evidence and reconstructions of their anatomy provide tantalizing clues. As mentioned earlier, the Neanderthal brain had a proportionally larger occipital lobe, suggesting a heightened reliance on vision. Their eyes were also larger than ours, particularly in low-light conditions, which may have given them an advantage in the dimly lit forests and caves they often inhabited. This enhanced vision may have been crucial for hunting, navigating their environment, and detecting potential predators.
Their sense of smell was likely also highly developed. The Neanderthal skull features a large nasal aperture and a complex nasal cavity, suggesting a keen sense of smell. This heightened olfactory sense would have been invaluable for detecting prey, identifying potential mates, and avoiding dangers such as predators or spoiled food.
While less is known about their hearing, reconstructions of the Neanderthal ear suggest that their hearing range may have been similar to that of modern humans. They likely possessed a keen sense of hearing, alert to the rustling of leaves, the snapping of twigs, and the calls of both prey and predator. The world of the Neanderthals, though different from our own, was rich in sensory information. Their adaptations, honed by generations of natural selection, allowed them to navigate this world with skill and precision, surviving and thriving in the challenging landscapes of the Pleistocene Epoch. The lives of Neanderthals were intricately intertwined with the rhythms of nature, their daily routines dictated by the ebb and flow of seasons and the availability of resources.
As hunter-gatherers, we relied on our intimate knowledge of the environment to secure food, find shelter, and navigate the challenges of a glacial world.
Their days were likely filled with a blend of demanding physical activity and moments of rest and social interaction, a balance essential for survival in the unforgiving landscapes they called home.
The pursuit of food, the cornerstone of our existence, demanded both individual skill and coordinated group effort.
Whether stalking large game across windswept plains or carefully gathering edible plants from the forest floor, Neanderthals honed their survival skills over generations, passing down their knowledge through a blend of observation, imitation, and experience.
Shelter, too, was paramount for survival, providing protection from the elements and a haven from predators.
Caves and rock shelters, natural havens in the often harsh terrain, offered refuge from the cold and a place to build fires, prepare food, and socialize.
In regions where natural shelters were scarce, we may have constructed temporary shelters from wood, animal hides, and other available materials. Our ingenuity tested by the limits of our environment.
Life for a Neanderthal was not simply about surviving from one day to the next. It was about thriving within the constraints of their world.
Our daily routines, though shaped by the demands of subsistence, were also imbued with elements of social bonding, cooperation, and perhaps even moments of leisure and reflection.
In the popular imagination, Neanderthals are often depicted as cave dwellers, their lives confined to the shadowy recesses of subterranean worlds. This image, while partially accurate, only tells a fraction of their story. The reality of Neanderthal habitation is far more complex and varied, reflecting their remarkable adaptability and resourcefulness in the face of changing environments and climates. While it is true that caves and rock shelters feature prominently in the archaeological record of Neanderthals, their choice of dwelling places was far more diverse, reflecting both the availability of natural shelters and their own adaptability. These natural formations provided a ready-made solution to the challenges posed by the Ice Age climate. But Neanderthals were not solely dependent on them. Caves and rock shelters, with their natural protection from the elements, offered obvious advantages, providing refuge from the cold, wind, and rain. These shelters were particularly valuable during harsh weather conditions, allowing Neanderthals to maintain a stable living environment even when the outside world was inhospitable. Inside these natural shelters, Neanderthals built fires for warmth and light, butchered their prey, and left behind a rich tapestry of artifacts that provide glimpses into their daily lives. The presence of hearths, tools, and animal bones within these caves tells us much about their diet, social structure, and even their cognitive abilities. These sites, often occupied for generations, preserve a remarkable record of Neanderthal activity, from discarded tools and animal bones to the subtle traces of hearths and sleeping areas. The layers of sediment within these caves act as a time capsule, preserving the story of Neanderthal life over thousands of years. However, Neanderthals were not limited to subterranean dwellings. They were highly adaptable and capable of thriving in a variety of environments. Their ability to exploit different types of habitats is a testament to their ingenuity and resilience. Archaeological evidence reveals that they also established open-air sites, particularly during milder periods or in regions where caves were scarce. These sites were often strategically located near water sources or other critical resources, ensuring that Neanderthals had access to the necessities of life. These open-air sites, often located near water sources or other critical resources, required Neanderthals to construct their own shelters, likely using perishable materials such as wood, branches, and animal hides. The construction of these shelters would have required significant skill and knowledge, further highlighting the sophistication of Neanderthal society. While the ephemeral nature of these open-air structures means they are less well preserved than cave sites, they nonetheless demonstrate the adaptability of Neanderthals and their ability to thrive in a variety of environments. The remains of these sites provide valuable insights into how Neanderthals adapted to different landscapes and climates. Neanderthal dwellings, whether nestled within the protective embrace of a cave or erected beneath the open sky, were more than just places of shelter. They were the backdrop for their lives, the settings for their social interactions, their rituals, and their enduring struggle for survival. These spaces were integral to their identity and culture, serving as the stage for the daily dramas of Neanderthal existence. From the intimate moments of family life to the communal activities that bound their groups together, these dwellings were the heart of Neanderthal society.
A diet for the ages. Reconstructing Neanderthal cuisine. The image of Neanderthals as brutish carnivores, feasting solely on the flesh of large game animals, has long been a staple of popular imagination. However, recent research paints a far more nuanced picture of their diet, revealing a surprisingly diverse and adaptable approach to food procurement. Neanderthals were skilled hunters, capable of bringing down large prey such as mammoths, rhinoceroses, and bison, but their diet extended far beyond meat. Analysis of Neanderthal teeth, bones, and even fossilized feces reveals a surprising reliance on plant foods, suggesting a more omnivorous diet than previously thought. Microscopic plant remains trapped in Neanderthal teeth, for example, indicate that they consumed a variety of roots, tubers, fruits, and seeds. These plant foods, while often overlooked in reconstructions of prehistoric diets, likely provided essential vitamins, minerals, and carbohydrates, supplementing the protein and fat obtained from hunting. The relative proportions of meat and plant foods in the Neanderthal diet likely varied depending on location, season, and resource availability. In colder climates or during glacial periods, when plant foods were scarce, they may have relied more heavily on hunting, while in warmer regions or during interglacial periods, plant foods likely played a more significant role in their subsistence. This dietary flexibility, a hallmark of successful hunter-gatherer societies, underscores the adaptability of Neanderthals and their ability to exploit a wide range of food resources to survive in a variety of environments. Kindred spirits. Comparing Neanderthals and modern humans. The discovery of Neanderthals in the 19th century sent shockwaves through the scientific community and ignited a debate that continues to this day. What is our relationship with these enigmatic hominins? Were they a separate species, destined to go extinct, or did they play a role in our own evolutionary journey? Over the past century and a half, painstaking research and remarkable fossil discoveries have gradually unveiled the secrets of our ancient cousins, revealing both striking similarities and intriguing differences between us. Neanderthals, with their robust build, prominent brow ridges, and distinctive skull shape, certainly differed in appearance from modern humans. Yet, beneath these anatomical distinctions lay a shared evolutionary heritage, a common ancestor that linked us together in the tapestry of life. Both Neanderthals and modern humans belonged to the genus Homo, a testament to our shared lineage and our place within the broader primate family tree. Beyond physical characteristics, Neanderthals exhibited remarkable cognitive abilities and cultural complexity, challenging the notion that they were primitive or intellectually inferior. They crafted sophisticated tools, hunted large game, controlled fire, and cared for their sick and injured. Evidence suggests they may have even engaged in symbolic behavior, hinting at a rich inner life that we are only beginning to understand. The comparison between Neanderthals and modern humans is a multifaceted endeavor, one that delves into the realms of genetics, anatomy, behavior, and culture. As we explore these fascinating parallels and divergences, we gain a deeper appreciation for the diversity of our hominin family tree and the remarkable story of human evolution.
Genetic connections, unraveling the threads of ancestry. The advent of genetic analysis has revolutionized our understanding of human evolution, providing unprecedented insights into the relationships between different hominin lineages. In a groundbreaking achievement, scientists successfully extracted and sequenced DNA from Neanderthal fossils, opening a new window into their past and revealing their genetic connections to modern humans. The results of these analyses sent shockwaves through the scientific community. Neanderthals and modern humans had interbred, leaving a subtle but undeniable genetic legacy in many modern populations. The implications of this discovery were profound, challenging the traditional view of human evolution as a linear progression and replacing it with a more complex and interconnected narrative. Analysis of Neanderthal DNA revealed that they shared a surprising amount of genetic material with modern humans, indicating a closer evolutionary relationship than previously thought. This genetic overlap provided compelling evidence that Neanderthals and modern humans had not only encountered each other, but had also interbred, their genetic lineages intertwining during periods of coexistence. The extent of Neanderthal ancestry in modern human populations varies geographically, with individuals of European and Asian descent carrying a small but significant percentage of Neanderthal DNA. This genetic legacy, a testament to the interconnectedness of our past, has implications for our understanding of human health, disease susceptibility, and even our physical appearance. Section 3. A legacy in our genes, Neanderthal DNA in modern populations. The discovery of Neanderthal DNA in modern human populations has sparked a flurry of research aimed at understanding the implications of this genetic inheritance. While the percentage of Neanderthal DNA in most modern humans is relatively small, typically around 1 to 4%, these genetic remnants have left their mark on our biology, influencing traits ranging from our immune system to our skin and hair color. Some researchers believe that Neanderthal genes may have provided early modern humans with an adaptive advantage, helping them to survive and thrive in new environments as they migrated out of Africa. For example, certain Neanderthal genes are involved in immune responses to pathogens, potentially providing increased resistance to diseases that were common in Europe and Asia. Other Neanderthal genes are associated with skin pigmentation, suggesting that they may have contributed to the evolution of lighter skin tones in some populations and adaptation to lower levels of ultraviolet radiation in northern latitudes. However, not all Neanderthal genes were beneficial. Some studies suggest that certain Neanderthal variants may be associated with an increased risk of certain diseases, such as type 2 diabetes, Crohn's disease, and depression. The Neanderthal legacy in our genes is a complex tapestry of both advantageous and potentially detrimental traits, a testament to the intricate interplay between genetics, environment, and human health.
Section 4. Cognitive comparisons. Exploring similarities and differences. The question of Neanderthal intelligence has captivated scientists and the public alike for decades. Early depictions of Neanderthals often portrayed them as brutish and unintelligent, but archaeological and genetic evidence paints a far more nuanced picture. While their brains were structured differently from ours, with a larger occipital lobe and a smaller frontal lobe, Neanderthals exhibited remarkable cognitive abilities, suggesting a level of intelligence comparable to that of early modern humans. They crafted sophisticated tools, hunted large game, controlled fire, and cared for their sick and injured, all hallmarks of complex thought and social cooperation. One of the most enduring debates regarding Neanderthal cognition centers on their capacity for language. While they possessed the anatomical structures necessary for speech, including a hyoid bone similar to ours, the complexity and sophistication of their language remain a subject of speculation. Some researchers believe that Neanderthals may have had a rudimentary form of language, perhaps capable of communicating basic ideas and concepts, while others argue that they possessed a more complex grammatical structure, allowing for a wider range of expression. The Neanderthal capacity for language, though difficult to ascertain definitively, is a testament to their cognitive abilities and their potential for abstract thought and communication.
Section 1. The Neanderthal World, a Mosaic of Environments. Imagine stepping back in time, journeying to the landscapes inhabited by our Neanderthal cousins during the Pleistocene Epoch. Their world was a dynamic mosaic of diverse environments, shaped by the relentless advance and retreat of glaciers, and characterized by a rich tapestry of flora and fauna. From the windswept steppes of Central Asia to the forested valleys of Europe, Neanderthals adapted and thrived in a remarkable range of ecological settings. In the northern reaches of their range, where glacial ice sheets carved deep valleys and sculpted towering mountains, Neanderthals contended with frigid temperatures, short growing seasons, and a landscape dominated by coniferous forests and icy tundra. Here, their survival depended on their ability to hunt cold-adapted animals, such as woolly mammoths, reindeer, and musk oxen, and to find shelter from the elements in caves or rock shelters. Further south, in regions less impacted by glacial advance, Neanderthals inhabited more temperate environments, including deciduous forests, open woodlands, and grasslands. These regions offered a greater diversity of plant and animal life, providing Neanderthals with a wider range of food options and requiring them to adapt their hunting and gathering strategies accordingly. Their ability to thrive in such a variety of environments speaks to the adaptability and resilience of Neanderthals, their mastery of fire, their sophisticated tool-making skills, and their deep understanding of the natural world around them. Section 2. Adapting to changed Neanderthals in a fluctuating climate. The Pleistocene Epoch, a period spanning over 2 million years, was characterized by dramatic climatic fluctuations, with glacial periods of intense cold interspersed with warmer interglacial periods. These cyclical shifts in climate had a profound impact on plant and animal life, forcing Neanderthals to adapt to ever-changing environmental conditions. During glacial periods, when ice sheets advanced and temperatures plummeted, Neanderthals faced the challenges of finding food and shelter in a landscape increasingly dominated by ice and snow. Their robust physique and adaptations to cold, such as their stocky build and large nasal aperture, would have provided some protection from the elements, but their survival depended on their ability to innovate and adapt their behavior. During interglacial periods when temperatures rose and glaciers retreated, the environment transformed, offering new opportunities and challenges. Forests expanded, providing habitat for a greater diversity of animals, while grasslands gave way to woodlands. These warmer periods allowed Neanderthals to expand their range into previously inhospitable regions, but they also brought them into contact with new predators and competitors. The ability of Neanderthals to not only survive but to thrive through these dramatic climatic swings is a testament to their adaptability, their resourcefulness, and their capacity for innovation. They adjusted their hunting strategies, modified their tools, and shifted their settlement patterns in response to changing environmental conditions, demonstrating a remarkable ability to cope with the challenges of a dynamic and unpredictable world.
Section 3. Neanderthals and their neighbors. Interactions with other species. The world inhabited by Neanderthals was teeming with life, a tapestry of diverse species, some familiar and others long extinct. As they navigated this ancient landscape, Neanderthals encountered a menagerie of creatures, from massive herbivores like woolly mammoths and woolly rhinoceroses to fearsome predators like cave lions, cave bears, and hyenas. Their interactions with these animals were multifaceted, encompassing both competition and cooperation. Neanderthals were skilled hunters, capable of bringing down large game, but they also faced competition for resources from other predators, some of which may have viewed them as prey. Evidence from fossil sites suggests that Neanderthals sometimes fell victim to predators, their bones bearing the telltale marks of teeth and claws. However, Their relationship with other animals extended beyond predator-prey dynamics. Neanderthals may have scavenged carcasses left behind by other predators, and there is evidence that they sometimes interacted with other hominins, including early modern humans. The nature of these interactions remains a subject of debate among scientists, but genetic evidence suggests that interbreeding occurred between Neanderthals and modern humans, leaving a lasting legacy in our own DNA. The world of the Neanderthals was a complex web of ecological relationships, where survival depended on their ability to navigate a dynamic and often challenging environment, interacting with a diverse cast of creatures, both friend and foe.
Grunts and murmurs to illustrate interaction.
Section 4. The Tools of Survival. The Mousterian Industry and its Refinements. Neanderthals were masters of stone tool technology, their craftsmanship a testament to their ingenuity and adaptability. Their signature tool industry, known as the Mousterian, emerged around 300,000 years ago and persisted for hundreds of thousands of years, a testament to its effectiveness and versatility. The Mousterian industry was characterized by a sophisticated technique known as the Levallois method, which involved carefully preparing a stone core to produce flakes of predetermined size and shape. These flakes were then further shaped and refined into a variety of tools, each designed for a specific purpose. Among the most common Mousterian tools were hand axes, versatile implements used for a variety of tasks, from butchering animals to woodworking. Scrapers, as their name suggests, were used to scrape hides, prepare food, and shape other materials. Points, often hafted to wooden shafts, served as spear tips or projectiles, enabling Neanderthals to hunt from a distance. The Mousterian industry was not static, but evolved over time, reflecting both regional variations and technological innovations. In some regions, Neanderthals developed specialized tools for specific tasks, such as processing hides or working with wood. The diversity and sophistication of their tools underscore the adaptability of Neanderthals and their ability to tailor their technology to the demands of their environment. Section 5. Beyond Function. Hints of Neanderthal Symbolism and Art. For decades, the question of whether Neanderthals possessed symbolic thought and engaged in artistic expression remained a subject of intense debate among scientists. While the archaeological record of Neanderthal symbolism is less extensive than that of early modern humans, recent discoveries have challenged the notion that they were purely pragmatic and lacking in symbolic capacity. One compelling line of evidence comes from the intentional use of pigments, such as ochre and manganese dioxide, found at Neanderthal sites. These pigments, often applied to objects or surfaces, suggest an interest in color and decoration, perhaps for symbolic or ritualistic purposes. Other tantalizing hints of Neanderthal symbolism come from the deliberate arrangement of objects, such as animal bones or stones, in patterns that seem to go beyond purely functional explanations. While the meaning of these arrangements remains elusive, they suggest an intentionality and perhaps even a sense of aesthetics that were once thought to be unique to modern humans. Perhaps the most striking evidence of Neanderthal symbolic behavior comes from the recent discovery of engravings on cave walls at several sites in Europe. These engravings, often abstract in nature, predate the arrival of modern humans in these regions, suggesting that Neanderthals were capable of creating symbolic representations of their world.
Section 1. The Last Neanderthals, a Dispersing Lineage. As we have journeyed through the world of the Neanderthals, we have encountered a species remarkably adapted to the challenges of a glacial world. They were skilled hunters, adept toolmakers, and resourceful survivors who endured dramatic climatic fluctuations and navigated complex social landscapes. Yet, despite their resilience, the Neanderthal lineage eventually faded from the tapestry of life, leaving behind a legacy of questions that continue to intrigue and challenge us today. Around 40,000 years ago, the Neanderthal presence in Europe began to contract, their once extensive range fragmenting into isolated pockets. The reasons behind this decline are complex and multifaceted, likely involving a combination of factors that ultimately proved insurmountable. One contributing factor may have been the arrival of modern humans, Homo sapiens, who entered Europe around this time, bringing with them new technologies, social structures, and perhaps even diseases to which Neanderthals had little immunity. The competition for resources, combined with the potential for intergroup conflict, may have placed additional pressure on Neanderthal populations already struggling to cope with changing environmental conditions. As the climate continued to fluctuate, with periods of intense cold punctuated by warmer interludes, Neanderthals faced the added challenge of adapting to a landscape in flux. Their traditional hunting grounds may have shifted, prey animals may have become scarce, and their reliance on familiar resources may have been disrupted. The last Neanderthals, clinging to survival in scattered enclaves across Europe, represent a poignant reminder of the fragility of life and the relentless march of time. Section 2. Climate and competition factors in the Neanderthal demise. The extinction of the Neanderthals, a topic that has sparked endless debate and speculation among scientists for over a century, remains one of the most enduring mysteries in human evolution. The Neanderthals, our closest extinct human relatives, roamed Europe and parts of Asia for hundreds of thousands of years before mysteriously disappearing around 40,000 years ago. Their disappearance coincides with the arrival of modern humans in Europe, leading to numerous theories about what might have caused their extinction. While a single definitive cause remains elusive, a growing body of evidence suggests that a complex interplay of factors, including climate change, competition with modern humans, and perhaps even factors we have yet to uncover, contributed to their demise. Theories range from the impact of volcanic eruptions to the spread of diseases brought by modern humans. Each of these factors, on its own, might not have been enough to drive the Neanderthals to extinction, but together, they created a perfect storm of challenges. Climate change, a recurring theme throughout the Pleistocene Epoch, undoubtedly played a role in the Neanderthal story. The Pleistocene, often referred to as the Ice Age, was characterized by repeated glacial cycles, where massive ice sheets would advance and retreat over large parts of the northern hemisphere. These cycles had profound effects on the environment, altering habitats and forcing species to adapt to rapidly changing conditions. The glacial cycles that characterized this period, with their dramatic swings in temperature and precipitation, placed immense pressure on all life forms, forcing them to adapt or perish. For the Neanderthals, who were well adapted to cold climates, these changes would have presented significant challenges. As the ice sheets advanced, they would have pushed Neanderthal populations southward, compressing them into smaller areas and increasing competition for resources. Neanderthals, though well adapted to cold climates, were not immune to the effects of these climatic fluctuations. Their survival strategies, which included hunting large game and foraging for plant foods, would have been severely tested by the changing environment. As the climate fluctuated, the availability of their traditional food sources would have become unpredictable, forcing them to adapt their hunting and foraging strategies. As glaciers advanced and retreated, their traditional hunting grounds would have shifted, prey animals may have become scarce, and their reliance on familiar resources may have been disrupted. The large herbivores that Neanderthals relied on, such as mammoths and woolly rhinoceroses, would have migrated in response to the changing climate, making them harder to find and hunt. This would have placed additional stress on Neanderthal populations, already struggling to survive in a harsh and unforgiving environment. The arrival of modern humans in Europe, coinciding with a period of significant climatic instability, added another layer of complexity to the Neanderthal story. Modern humans, with their more advanced technology and social structures, would have presented a formidable challenge to the Neanderthals. The two species coexisted for several thousand years, and during this time, they would have competed for the same resources, such as food and shelter. While the nature and extent of interactions between Neanderthals and modern humans remain a subject of debate, it is clear that their coexistence had implications for both groups. Some evidence suggests that there may have been interbreeding between the two species, as modern humans outside of Africa carry a small percentage of Neanderthal DNA. However, the extent to which this interbreeding occurred and its impact on Neanderthal populations is still a matter of ongoing research. Modern humans, with their more advanced toolkits, broader dietary range, and perhaps even superior cognitive abilities, may have outcompeted Neanderthals for scarce resources. The tools used by modern humans were more sophisticated and versatile, allowing them to exploit a wider range of resources. Additionally, modern humans had more complex social structures and communication abilities, which would have given them an advantage in coordinating group activities, such as hunting and gathering. The potential for intergroup conflict, while difficult to prove definitively, cannot be ruled out. Competition for resources could have led to violent encounters between Neanderthals and modern humans. Archaeological evidence of trauma on Neanderthal skeletons suggests that they may have experienced violent conflicts, although it is not always clear whether these injuries were the result of intergroup conflict or other causes. The Neanderthal demise, a gradual process that unfolded over thousands of years, was likely the result of a perfect storm of challenges, a confluence of environmental pressures and competitive disadvantages that ultimately proved insurmountable. As the climate continued to change and modern humans spread across Europe, the Neanderthals found themselves increasingly squeezed out of their traditional territories. Their populations dwindled, and eventually they disappeared from the archaeological record, leaving behind only their bones and the tools they used. Recent advances in genetic research have provided new insights into the Neanderthal extinction. By analyzing ancient DNA, scientists have been able to reconstruct aspects of Neanderthal biology and behavior that were previously unknown. These studies have revealed that Neanderthals and modern humans shared a common ancestor around 600,000 years ago, and that the two species interbred at various points in their history. The genetic evidence also suggests that Neanderthals had a smaller population size compared to modern humans, which would have made them more vulnerable to environmental changes and competition. Smaller populations are more susceptible to genetic drift and inbreeding, which can reduce genetic diversity and increase the risk of extinction. This genetic bottleneck, combined with the other challenges they faced, may have contributed to their eventual demise. Despite their eventual extinction, Neanderthals were a highly successful species in their own right. They were skilled toolmakers, capable of creating a variety of tools for different purposes. They also used fire, built shelters, and had complex social structures. Evidence suggests that they cared for their sick and injured, buried their dead, and may have even had symbolic or artistic practices. The discovery of Neanderthal art and artifacts has challenged the notion that they were less cognitively advanced than modern humans. Cave paintings, carved objects, and other forms of symbolic expression indicate that Neanderthals had a rich cultural life. These findings have led to a re-evaluation of their cognitive abilities and their place in the human evolutionary story. The study of Neanderthals continues to evolve as new discoveries are made. Each new find adds to our understanding of who they were and how they lived. As archaeologists and geneticists uncover more evidence, the story of the Neanderthals becomes more complex and nuanced. Their extinction, once seen as a straightforward case of being outcompeted by modern humans, is now understood to be the result of multiple interacting factors. The legacy of the Neanderthals lives on in modern humans. The small percentage of Neanderthal DNA found in non-African populations is a reminder of our shared history. This genetic legacy has implications for our understanding of human evolution and the ways in which different human species interacted and influenced each other. In many ways, the story of the Neanderthals is a story of resilience and adaptation. Despite the challenges they faced, they survived for hundreds of thousands of years in some of the most extreme environments on Earth. Their ability to adapt to changing conditions and their complex social behaviors are a testament to their ingenuity and resourcefulness. As we continue to study the Neanderthals, we gain a deeper appreciation for their place in the human family tree. Their story is not just one of extinction, but also one of survival, adaptation, and the enduring legacy they left behind. By understanding the factors that led to their demise, we can learn valuable lessons about our own species and the challenges we face in an ever-changing world. The quest to understand the Neanderthals is far from over. With each new discovery, we come closer to unraveling the mysteries of their existence and their eventual extinction. The study of Neanderthals is a dynamic and evolving field, one that continues to captivate scientists and the public alike. As we look to the past, we are reminded of the interconnectedness of all human species and the shared journey that has brought us to where we are today. In conclusion, the demise of the Neanderthals was not the result of a single event or factor, but rather a complex interplay of environmental, biological, and social challenges. Their story is a poignant reminder of the fragility of human existence and the resilience required to survive in a constantly changing world. As we continue to explore their history, we honor their legacy and the contributions they made to the human story. Thank you for watching.
The advent of genetic analysis has revolutionized our understanding of human evolution, revealing a tangled web of relationships between different hominin lineages. One of the most remarkable discoveries in recent decades has been the confirmation that Neanderthals and modern humans interbred, leaving a subtle but enduring genetic legacy in many modern populations. Analysis of Neanderthal DNA has revealed that they contributed approximately 1 to 4% of the genetic makeup of present-day people of European and Asian descent. This genetic inheritance, a testament to the interconnectedness of our past, has implications for our understanding of human health, disease susceptibility, and even our physical appearance. Some Neanderthal genes, for example, are involved in immune responses to pathogens, potentially providing increased resistance to diseases that were common in Europe and Asia. Other Neanderthal genes are associated with skin pigmentation, suggesting that they may have contributed to the evolution of lighter skin tones in some populations, an adaptation to lower levels of ultraviolet radiation in northern latitudes. However, not all Neanderthal genes were beneficial. Some studies suggest that certain Neanderthal variants may be associated with an increased risk of certain diseases, such as type 2 diabetes, Crohn's disease, and depression. The Neanderthal contribution to our genetic makeup is a complex mosaic of both advantageous and potentially detrimental traits, a testament to the intricate interplay between genetics, environment, and human health.
Neanderthals in popular culture, from misconceptions to new perspectives. The image of the Neanderthal has long captured the public imagination, inspiring countless works of art, literature, and film. Yet, their portrayal in popular culture has often been fraught with misconceptions, reflecting outdated scientific theories and societal biases that cast them as brutish, unintelligent, and inferior to modern humans. Early depictions of Neanderthals, influenced by 19th century notions of racial hierarchy and evolutionary progress, often portrayed them as ape-like creatures, hunched over, hairy, and incapable of complex thought or behavior. These caricatures, perpetuated in popular media and even in some scientific circles, reinforced the idea that Neanderthals were a primitive, evolutionary dead end, destined to be replaced by the superior modern human. However, as our understanding of Neanderthals has evolved, so too has their portrayal in popular culture. Recent documentaries, books, and films have embraced a more nuanced and scientifically accurate view of these ancient humans, highlighting their intelligence, adaptability, and cultural sophistication. They are increasingly depicted as complex individuals, capable of love, loss, and even art, challenging us to confront our preconceptions and to appreciate the shared humanity that binds us together across time and evolutionary divides. The evolving portrayal of Neanderthals in popular culture reflects a broader shift in our understanding of human evolution, one that embraces complexity, celebrates diversity, and recognizes the interconnectedness of all life on Earth. Unanswered questions and future discoveries. Despite decades of research and countless discoveries, the Neanderthals continue to hold many secrets, their story a tapestry woven with threads of mystery and intrigue. As we delve deeper into their world, new questions emerge, challenging our assumptions and pushing the boundaries of our understanding. The nature and extent of their interactions with modern humans, for example, remain a subject of intense debate. While genetic evidence confirms that interbreeding occurred, the frequency of such encounters, the social dynamics at play, and the implications for both groups are still being unraveled. The reasons behind the Neanderthal extinction, a topic that has captivated scientists for over a century, remain shrouded in uncertainty. While climate change, competition with modern humans, and other factors likely played a role, the precise sequence of events and the relative contributions of each factor continue to be debated. The full extent of Neanderthal cognitive abilities and cultural expressions is another area ripe for future exploration. While evidence of their tool-making skills, hunting prowess, and even symbolic behavior is mounting, we are only beginning to scratch the surface of their capabilities. Did they possess language as we know it? Did they have art, music, and storytelling traditions? These are just a few of the tantalizing questions that await further investigation. The study of Neanderthals is a dynamic field, fueled by new discoveries and technological advancements that promise to provide even greater insights into their lives and their place in our evolutionary past. A final farewell. Honoring the Neanderthal story. As we bid farewell to the Neanderthals, our ancient cousins who walked this earth for hundreds of thousands of years, we do so with a sense of awe and respect for their resilience, their ingenuity, and their enduring legacy. They were a testament to the diversity of our hominin lineage, a reminder that the path of human evolution was not a linear march toward modernity, but a complex and branching journey, filled with twists, turns, and unexpected encounters. Their story challenges us to confront our preconceptions about what it means to be human, to recognize the interconnectedness of all life on Earth, and to appreciate the remarkable tapestry of life that has unfolded on this planet over millions of years. Let us honor their memory by embracing the spirit of inquiry, by continuing to explore the mysteries of our past, and by celebrating the rich diversity of life, both past and present, that has shaped our world. The Neanderthals may be gone, but their story lives on, a timeless reminder of the power of adaptation, the importance of innovation, and the enduring legacy of our shared human journey.